I'm going to cover a couple topics today about Oracle running on Linux on Z. Keep this interactive as much as possible. Just ask lots of questions, particularly when we get into security, what's going on with that. We're going to get into a little bit of memory, what I've seen at different customers, CPU. But a little background, I've been an Oracle DBA for about 29, 30 years now, and about 10 years on IBM Z systems the last 10 years. And, you know, just being very biased, but I know configured properly, Oracle can beat any platform out there. I've gone against benchmarks and ran against competitor products and have always won in the benchmark if configured properly. I've worked in a lot of systems where they've not been configured properly. They've been given the Oracle 1 gig of memory, 1 I/O card, and 1 IFL, and they think it's going to blow away 100 cores of something else. So yes, it's great, but it needs to be configured properly to get all, tap out that power. So I'm going to start with Oracle 12.2, just give a little update of what's going on. This came out on Z Systems in June of 2017. We'll talk about R18, the next release that's coming out in a few minutes. Some of the new features that I thought might be applicable to the audience, you can now do encryption. You can migrate data between a system that's already got encrypted table spaces, let's say on Intel, to Linux on Z. Before that was a problem. If you've got the crypto keys on an Intel card stored there, that could be a little hard. But if it's stored on a file system, you can move the data now. You can also do online encryption. So while your database is running with Oracle, I can encrypt the databases using Oracle's TDE product. And we'll talk about some of the other encryption techniques that are available as we go through this presentation. One of the other things, too, is before Oracle, with its transparent data encryption product, you couldn't encrypt the system table space, which has the data dictionary, or the sysocs, which is where all the performance reports kind of sit. And then the undo is where, when you're doing an Oracle transaction, it will back up the data. Let's say if you're doing an insert or update of a record, it keeps the undo, the before image of that values in the undo table space. So you want those to be encrypted. So now with 12.2, all that's encrypted. Another new feature is compression of indexes for OLTP. So if you've got a data block, let's say maybe 4 rows in that data block, you can now compress it as an index block and put 40 rows in that block. And that will work well with OLTP workloads. Another feature that we're starting to see at a lot of our customers now is using Oracle Data Guard. And I've got a picture in the next slide. But what Oracle Data Guard will do is works well in the Z environment. It will protect your system from like a failure, from a storage failure, as well as a, like if you're doing maintenance to your LPAR. So in this example here, we're implementing the solution here where we've got on site, on the primary site, we've got 2 LPARs set up. So running Oracle on either LPAR. And what we do, we apply the log synchronously to the other LPAR. And what that does is if there's a type of storage failure, the system will stay up. The problem is right now they're just replicating from their primary system here to the DR using storage-based replication, which works great, but it takes them 18, 20 hours on a good day when it's all planned to cut over all the ancillary systems. So you've got all these feeder systems that got to move over, the app servers. So it's a big event to move over in the event of a failure. And they're like, we can't afford to take that type of downtime. We need to be able to fail over if there's a problem quickly. So this one configuration will allow them to take planned maintenance for ZVM or Linux patching, Oracle patching. If you take a hit on the storage server, you'll be able to still keep running. And then we leverage the synchronous, asynchronous backup of the storage solution to do the full DR if it craters and things like that. So this is something a couple of my customers are interested in. We've started implementing this at some high available places. So one of the things about security, I think there's been a lot of sessions on security. Patching is very important, security patches. One of the things that we're seeing is for the last 10 years or 8 years, the security patches for Linux on Z come out on the same date as any platform. Actually, sometimes even sooner than some of the HPs or some of the ancillary systems, because the DNA of Oracle is Linux. I mean, Oracle develops under Linux, and to port it to Linux on Z is a very easy port, and the patches come out, right away. So if there's a serious issue with Linux on Z, the patches are available right away, which is a good strength of the platform, one of the things we fought for. So when we're talking about security, it's layers of security. It's really important. Patching is probably number one. Making sure your Red Hat and SUSE patches come out on time, making sure your Oracle patches come out. So with Z and this solution running on Z systems, our patches come out, every quarterly on the quarterly updates. Some of the things that, some of the traps I've been falling into with the Oracle upgrades that I've been working with. I've got a few customers take the new IBM Z14, and they want to upgrade their Oracle from Oracle 10, but Oracle will only work on Red Hat 7 or SUSE 12 on a Z14. I think SLES 11 works, but I don't think, would you ever do that, Richard? Install SLES 11 on 14? I know, it's crazy, right? But people are trying to put really old versions of Oracle. They don't want to upgrade, so we've got to, drag them across. And so we're doing a lot of upgrade work right now. And one of the things that we recommend is just downloading this pre-upgrade utility from Oracle. It will check your database out, and actually it's mandatory. And I got caught on this, like working for a client in New York State. If we didn't run this script, we basically copied it over from Solaris to Z, and we upgraded it to a Z14 on new hardware, and I didn't run the script, and I had to go into the database and do a lot of changes to get it to do the upgrade. So if they would have just ran this script ahead of time, which checks out the database, says, hey, you need more memory, or this parameter has been deprecated, or this change needs to get done, it would have been a lot easier. So this is something that even I missed a couple times, and my customers is running this utility. So this is something that, just even a reminder for myself, make sure you do. Another big change that I'm starting to get caught on, I had a customer up in Canada fall into this problem, working with a couple state governments, is Oracle's changed their random number generator. So they basically have gone from using dev urandom, which basically some people say is not secure. I mean, you get different readings. Some people say it is secure, some people it isn't. But what happens, what we're seeing is you can log in 4 or 5 times, and then the 5th time, get like invalid username password. And you're like, what the hell? What's going on? And it's basically, it's running out of entropy. Basically, entropy is the number of randomized numbers that are available. And the good thing about Z is we have a lot of options. We can use, the crypto card, we can use CPAC-F and all that. But what the news is, Oracle 12.2 uses a lot of random number generators just in the installation and in different places, even authentication of logging in. So we can configure our new machines with different methodologies. So one of the things that I always get confused on is, am I doing a Red Hat install or am I doing a SUSE install? And one of the things is that what SUSE uses is called have GED. I think, am I saying that right? Have GED. And if you have the IBM crypto card installed, Crypto Express 6S, you have to shut that off, actually. You're supposed to shut that service off and then leverage it and configure it that way to leverage the card. If you're using Red Hat, what I like to use is the CPAC-F. And what I do is I basically run a mod PRG, and that gets me this p-random. And I basically configure Red Hat to use the CPAC-F. If I have the crypto card, I can use that as well. But this is something that we're seeing some errors, the odd little thing, and we have, on a Z system, we have the capability to leverage our, crypto card and our CPAC-F crypto processors to do. You experience anything like that with any of the softwares you installed, like Mongo or anything, Richard? Like, problems with entropy or anything like that? Okay, so just an Oracle thing. But yeah, Oracle changed. In 12.1 it was fine. 12.2, And all new releases, you got to have, it's changed to go dev random, and which puts this problem if you can run into, not enough entropy. Okay, so another capability that is in 12c is data redaction capability. So what we've got now is with Oracle, you can now set it up so you can hide the salary columns and you can hide the, social security number. These columns can be redacted. So if somebody like that doesn't need access, let's say you got a call center, you can redact so they don't see the social security number and all that other stuff. So we got the security patching, we got data redaction, and now we're going to get into encryption. All right. Oh, one question, I think this is a question for Rich and his team. Does anybody here do software certifications of products, like with Red Hat or SUSE or anything like that? Anybody else doing that, certifications? Okay, because Oracle's changed its release strategy. Before, we had like Oracle 11.2 back in 2010, and it ran for about 5 years, and people are still running 11.2, a lot of people. So it had like a, 9-year runway, maybe even 10, right? And Oracle 12 come out, and, people are still using it, 12.1, but Oracle just announced that the new releases are going to be like on these 2 or 3 year cycles now. So this R18 that's coming out, and it's going to be available on Z this year. It's out. I know people working with it. I know it's going to come out. But basically, it's an Oracle point release. But what they're making us do is they're making us recertify against Red Hat and SUSE and all that other stuff. And I'm worried about all the vendor apps that have to do this as well for just a minor point release. Before we got away with, Red Hat 7 or SLES 12, we're good for, Service Pack 1, 2, 3, 4, and Red Hat 7, 1, 2, 3, 4, 5. Yes, Jim?
So they're calling it release 18, but it's actually 12.2.02.
Yes. Correct.
Each one of these 18, 19 going to have a 10-year cycle, or before they've always done the point release?
Yeah. Look at 12.201. It's only got like a 3-year cycle, and then it's gone, right? And it's going to be out of support. And then release 18 is only going to have a 3-year cycle as well.
But what about in the previous?
Well, this is premier support right here. I mean, it's basically going to be, that's the life cycle that they're looking at. And then they're going to put it into what's called extended support, and you're going to have to pay extra for it. So it is a big change. And that's why I'm kind of talking to the audience. To me, it's just a point change, right? 12.202, right? They should just keep the certs. But they're making us, recert and test everything out. And I mean, it's a lot of work for us, and we'll do it. But for other vendors that have to certify the products, I'm worried. Yes.
So the libraries are now being set. Used to be we had some library named .12, .something. Now they're going to be changing every 3 years, like .18.
Every year. Not every 3 years. Every year. Every year. They're going to go R18, R19.
Well, is 18 and 19, is it just a marketing thing, or is it actually?
No. They're trying to reserve the right to throw new functionality in there before, with a point change, which is kind of a maintenance release, bug fixes, minor things. They're basically coming out with 18 and 19 as like majors. But 19 will be the terminal release of the 12.2 stream. So that's really where you want to be, like kind of like the 11.204 customer. You got like 9 or 10 years out of it. Really, 19 is where I would tell customers to go. R18 is going to come out. It's going to be great. You can tinker it. But really, you should plan on 19. It's going to have a longer runway. So.
Is there a release schedule yet for this?
Well, I can't say any release dates because I got to take the 5th on that. But what I can do is it's published on Oracle's website that it's going to be second half of 2018 is the official published date. And that's what we're allowed to tell people. But, it'll be out soon. So this is the big question. You know, I'm really worried about the certification cycles, how this thing's going to flush out. I mean, people had their pitchforks out and rioted. They're taking 11.204 out of service, and they extended it over a couple of years. So we'll see what happens. But it's something that, you know, I just want to make people a little aware of. I think we talked about this at the last share. One of the things that I had to get used to with the new OS distros is the services and systemd, because I had all these scripts set up to automate. You know, I don't want to be up at 2 a.m. or working with a team of DBAs up at 2 a.m. to shut down the Oracle database and then having to restart it. Or who knows what Barton's going to do to his system. He's going to reboot it. You don't want your systems to come up. You want it automated. And so, or if they're playing, what's that game they always play? Minecraft or something like that. Crash your server. Whatever. You know, I don't want to be called at 2 in the morning or 4 in the morning. I want it to be automated. So this is basically, you know, something where the dbaura.service is a script that helps create basically that will automate that. So I can basically just say, you know, my stuff will come down automatically and come up automatically. If you're running rack, they've got the services built in. It'll do it automatically. But this is something that, you know, is available there. All right. So another feature that's kind of unique to Z that we have is we have the RPM checker. So you can basically do a yum install, and it'll bring in all the packages for you automatically to do the Oracle install. Or with SUSE, you can use the Zyper to do the install. Are you started using that? Or do you just put them in by, you know, singularly? No, when you install Oracle, do you like put them in one at a time, install the RPMs, or do you just like automatically? Okay. That's the way to do it, for sure. Okay, and then we talked about the kernel changes on the last share. Just want to make sure anyone knew that swappiness has gone from 0 to 1, right? You still do that, 1? Yep. And then panic on ops, OOPS, that's something in there to basically before what we saw was you couldn't get a kernel dump in time when a system crashed. This now gives you a shot at it. A lot of people don't set up enough spool space and stuff like that to get the dumps anyways, but hopefully our lab services guys, that's part of the things you guys fight for a lot of times. But that's important when you're trying to troubleshoot problems. Like I said, I got a customer that's trying to go from Red Hat 5.11 to 7, and they're seeing some issues with just the upgrade. They're trying to get on the new box, do the right thing, but you know they're seeing they run their systems really hot, 100% CPU. They're starting to see file systems unmount and things like that, and we really need those dumps to get them to Red Hat support to do that analysis. So that's why setting up your databases with this and the spool space is important, so we can help troubleshoot those problems. All right, so I stole this triangle from your presentation, thank you. And what we're trying to do with Oracle now is we're trying to add in an encryption story. So what we can do with Oracle now is it's kind of the, we have the PKCS 11 for the app tier. We can do protection there. I know you've written a good paper on that. You did what, SSL and a whole bunch. Encourage, is it a red book or red piece that you did, or what was it? Yeah. Richard Young's, your white paper too. I mean, I look at it all the time. There's a lot of good stuff in there. But basically what we have in place is we have 4 really tiers of encryption capabilities. A lot of my customers are using storage-based encryption today. It passes audit. They're basically in compliance. They put their tape and storage there, and it's enough to kind of get by with that level of encryption. Moving up the chain now, with the pervasive encryption story we have, we can now use dmcrypt to encrypt databases at the Linux layer, which is a great capability. Not only can you do it for file system, but Oracle ASM as well. and we'll get into that in a bit. And then you can also go up another tier inside the database. You can even encrypt the table spaces if you want. You can use what's called columnar compression as well. Columnar encryption. So let's say you don't want to encrypt the whole database, just maybe a couple columns, like the social security number. You can do that. So with the SSL, what you have to do with Oracle is you basically set up a wallet, either with a hardware security module, or you set it up with on a file system, which obviously you want to use it on a Crypto Express card if possible. And then what you do with the Oracle listener is you set up a listener instead of being, on port 1521, which most databases kind of use. You set it up with TCPS and port whatever port you want. And that has to be set up on the client and the server, and then the listener, all the traffic between your app server and the database server will be encrypted. So that's how you kind of do it with the application stack. So storage-based encryption, I believe it uses AES XT256, kind of a standard out there, at least what our storage servers do. And then when we work with Oracle databases with transparent data encryption, Oracle's product, what we're seeing with no encryption and transparent data encryption, we're seeing about a 50% increase in CPU for that workload between the two. So it is kind of pricey from a CPU perspective, but I will note that the transaction rate was the same. So we were running about 2,000 or 3,000 transactions a second, and the rate was the same, but we had a bit of a CPU cost there, 50%. But with the new de-encrypt capability, and thanks to the red papers that you guys generated, there's a really good security red book that just came out with the link here. We can now, what we did in our testing is we set up an Oracle ASM disk group with basically running a sales order entry system with, with the database disks either non-encrypted or encrypted. And we're able to move the data between the two while the system is running. And we can run with ASM. And the key thing here is the dev mapper. Basically, when you set up the crypt setup, you run these commands. And one of the things that I've done is I've just gone with the defaults in the red book. One of the things I want to try, maybe later on, is the different block sizes to get different types of rates. Right now, we're using a 4K block size in our database size. This command here is the sectors of 512, I believe, right, Mike? That's right from the red book. And what we do is we set it up with the Linux Unified, I'm trying to think what the K stands for, but kernel security, I think, something like that. So basically, we're seeing, like I said, we're seeing really good performance results with this type of format. One of the things I will add, and I don't know if it's in the works or not, but when I was doing my testing, I wanted to see the hardware stats go up. There's something called ICA stats that'll show the, how much hardware and how much software encryption you're doing. And I didn't see that happening. And the only way we could do that is run the LPAR on the metal, and then we could run CPACF stats that way. So there's a link here to do that in LPAR mode where you can kind of see the, how much of the CPACF processor you're using for the workload. So hopefully that's something that ZVM will pick up at some point.
So you don't ever have to worry about running out of capacity on the CPACF. Each CP has its own CPACF, the operations are synchronous. So from that point of view, you have CPU capacity, you have CPACF capacity.
Yep, I mean that's the good thing. On each chip has each silicon has a CPACF that's available. So if you have 30, each core, right?
If you have, each single module chip has up to 10 cores, and each of those cores has its own CPU.
Right, each socket, I guess, is the right way. So one of the tools I use, and I'm going to show a couple tools here, if I'm still connected, I hope. One tool I use is called Silly Little Oracle Benchmark. And what this tool is it's from a guy who used to work actually at IBM on Sequent, and worked with Numa and all that. And then he's gone around to Oracle, worked in their development labs, helped them develop Exadata. He's at Amazon right now. But he publishes this tool that basically allows you to kind of test different scenarios. So what's the percentage difference between running my database encrypted or non-encrypted? And what the good thing about the tool is it runs without any contention in the database. It basically does random access to the system. So it's a pretty good little test. So this is what, when I ran my pure test, and I'm going to kind of show you how I run the test real quick. So basically what I do is we basically run a workload, and in this case I'm running, I guess it didn't flip over. So it's kind of hard to see, but basically what we're doing is we're running basically the silly little Oracle benchmark on a non-encrypted file system right now. And what this does is it's just going to, read and write to this file system basically that's set up that's non-encrypted, and we can run the same test encrypted. And like I said, the results that we're seeing right now, when I ran the tests, we ran with, let's say, this is a Z14 with 8 IFLs. So I've been testing with 8 threads or 16 threads. We also tested with updates, like how much insert, update, and delete you're doing, because different workloads vary. So I did, testing with insert updates. We tested longer durations. And pretty much we're seeing, 2%, 2.4, 2.1, kind of in that ballpark. This is a shared system, shared storage. There's going to be variability. You're not going to be guaranteed a certain vulnerability. But to run your entire database, the system, the undo, the redo, the entire database, and only get a 2.4% encryption or 2.4% performance hit, that's pretty good. This one is SLES 12, SP2, latest kernel. No, I mean the latest SP2. So I got the latest kernel from January. That's the way I can say it. For SP2s. Yeah, probably. But it is the most recent of the SP2 kernels that are available, is what I was running. So basically what we do, and just flipping back to this, it should be done in about a minute. Got another one to show you guys. But back to the results. Like I said, we're running around 2%, and this is the reads, and the updates are about the same, like 2 or 3%. So I'd have no problems, with this pervasive encryption story, since you can run Oracle ASM as well, of running your databases and not taking a hit from a performance perspective, on a Z14 at least. We've done tests on the 13 and the EC12, and the CPAC-F's available there as well, but you take a little bit more of a performance hit on that. So in this example, okay, it's just finishing up. So when this test's done, it collects IOStat. If you guys are familiar with Linux, IOStat and VMstat are kind of the basic Linux collection tools. But it also does what's called an Oracle's AWR report, which is Automatic Workload Repository Report, AWR. So it takes, this test runs a snap at the beginning and the end. So we're just going to take a quick look at that. And in the AWR report, in this workload that I was running, we can see we're running about 183,000 reads per second. That's kind of the run rate over that 3-minute test. And that's the direct path read was about 1.5 milliseconds. That's kind of what the time of the user I/O was about 1.5 seconds. So now we'll come back to this. I'm just going to switch to another database that's going to be, this database is encrypted, and it's going to run the same test. And we'll come back to it, and we'll look at the rates to show that we're kind of in that 2% range. Okay. So another thing we've done, we also tested this workload not only with the silly little Oracle benchmark, but we tested with another tool called SwingBench, which is a tool from Dominic Giles, another Oracle employee. And what this does is it kind of tests more of an order entry, OLTP workload, so just basically entering orders, different types of things like that. And we really stressed it out. We went with 5,000 users. We just hammered the system. And in this test, you know, we saw the SUSE CPU go up a little bit, which is kind of expected with dmcrypt and stuff. But the transactions rate stayed the same. You know, the number of transactions per second, you know, still a little bit less, but we're talking fractions here. So a small increase in time, and we're seeing about 1 to 3%, and that's consistent with what we're seeing with other software products running with the CPAC-F. And I haven't tried SLES 12 SP3. So.
When you get a more current Linux, the numbers maybe a little better. What do you mean by all the exploitation is there? In terms of, I think if you're using like XTS mode, in terms of getting the benefit out of the Z14 CPACF, that should all be there. It's all there. Because the XTS mode instruction existed on Z13, you know, so the difference between Z13 and Z14 is you don't have to issue a new instruction, but that existing instruction is being accelerated by up to 7 times based on the block size of the data. For that case, it's transparent. There are some modes, like GCM mode, that requires you to have encoded a specific new instruction. But if you're using XDS, it should be transparent. Okay.
Yeah, and like I said, that's the kind of the kernels I had. We'll do some testing with Red Hat 7 as well, 7.5, beta. I don't know.
So I think the one difference probably is you're using clear key versus protected.
Yes, that's another great point. I mean, one thing to note, as Michael said, we're using clear key in this test. When protected key comes out, when the Linux distros roll it in, they tell me they've rolled it in. I believe them. It'll be soon, I guess. But once that's there, we'll test that out as well, obviously. Because that's where you want to be. You don't want your keys to be stored on a file system or shared file system, your security keys. I mean, it works and you can protect it. And for today, you can kind of get set up for it. But the optimal solution is putting your encryption keys on a Crypto Express card. And then that's the Cadillac.
There'd be no difference in performance between clear key and protected key. It's just more secure. It would be, there's a nominal difference, but from a, it's not going to make a huge difference to the results. So like you're talking 1 to 3% versus meaningless. So it's probably tens of percent. Oh, even less. Okay.
Yeah, I agree. 1 to 3% is kind of like, exactly. And you don't know in a shared environment, right? You're sharing your disks, you're sharing the IFLs. Even though Prism does a really good job and you're running your LPAR, there's still going to be variability. All right, so we're going to move on to a little bit about memory and disk. This new 12.2 release, they come up with this new management disk group. So I've got customers that are trying to install this, and they're like, hey, I need another 40 gig of disk space just for this management disk group now. And I had no idea. This is like, it was buried in some install notes from Oracle for 12.2. And I've had cases also where customers, they've got a brand new Z14, they've gone from a Z13 S, they've bought a brand new Z14, they're moving their Oracle 10 databases up to Oracle 12 and move up to SLES 12. They're doing all the right things, but then their database is having a little bit of a problem. And what we're finding is that Oracle 12 needs a little bit of extra more memory than the Oracle 10 and the Oracle 11. So that's one of the things we've done is bumped up the memory quite a bit. And this is a customer in California here where we're getting Oracle errors and problems, and we basically increased the guests from 2 to 2.5 gig. Wasn't asking for much, but they got a lot of memory on their new Z14 anyways, that were kind of extra. And then we upgraded the SGA and the PGA. We kind of carved up that half a gig and gave it to that, and the customer was able to, resolve all the issues, and the upgrade went successful, and they were able to find. So that's just kind of the moral of the story is, as we move these people to the newer hardware and architectures, we may want to just throw a little bit of extra memory to Oracle to kind of help out. And I kind of got a demo to that effect.
But this is a one-time thing. Won't change or go up during normal.
Well, I don't know what's going to happen with this R18 from Oracle and R19. Who knows what they're going to do to us there. But right now, people have to upgrade their OS because of going to Z14 to be on SLES 12 or Red Hat 7. They're bringing their Oracle databases to the new version as well. Sorry about this. All right, so this is one of my favorite things to do. Last time I kind of showed this, and hopefully it showed up. Last time I did this demo in, where were we? Where's the last share? Was it? Sorry? Providence. I can't even remember. So we're in Providence, and I did this, and the demo's not showing, so that's great. How do I shake this thing out? Okay. Oh, it's got to look at this. So back to that AWR test. This was running encrypted before. And see, we're running 202,000 logical reads, which was, I think we were running around 205 on the other test. So the 2% rule still applies here. But this next test I want to kind of run, this is using swing bench. So with all these different claims and whatever, every workload is different. It's very important that you test your own workload and do your own tests. These are just kind of examples of what I do. So I ran the slob test for kind of the encryption test. This is going to be kind of the memory test. One of the things is DBAs. This is called this is called swing bench. And what's cool about this is the green is kind of user CPU. So this is actually Oracle CPU time. The red is Linux kernel time. So, if you're doing a lot of encryption, you may see a lot of red in there. And the blue is I/O wait. So, I'm seeing this at a lot of customers now that they're seeing a lot of I/O wait in their databases. They're spending a lot of time doing I/O wait. So, you can, we can add cards, we can do things like that. But sometimes the obvious thing is just to, add a little bit more memory to the database. And in this case, what I'm going to do is I'm just going to add 2 gig to the database. Okay. So while the database was running, I added about 2 gig of database, or 2 gig of memory, and my transaction rate is just just went way up there. And you can see now we're on CPU. This is where you want to be. You want to be in the green. This is all running Oracle. It's running smooth. It's happy now. Before it was really complaining and yelling. It was all without I/O wait. So just another 2 gig of memory to this database was able to make a big difference. And the transaction rates have gone from, 30 or 40 up to 2,000, 3,000 transactions a second just by giving the database a little bit of memory. So, we can do things with the storage, but Oracle likes its memory, and if the AWR says, hey, I could use a little bit more memory to help run more efficiently, you kind of want to do that.
Rules of thumb saying even the size of the database, this is a amount of this little bit of memory you need to add?
Good question. There's really no rule of thumb from current slide. So generally the question was, is there any rule of thumb? I mean, I think some people have said 32 gig of memory per IFL. I think on the Z14 it's more 64 gig per IFL. those are, if you got nothing, that's what you use. But you really want to get data from the system if you can. And here's an actual example from a customer where, they, production, it's showing that if I could add a little bit of memory, in this case we added like 20 gig of memory, we went from 373,000 or 373 million reads to 278 million reads. But their development system, if I would have done the same change in their QA and dev, there'd be no effect of the, it would cause no effect. So it would be wasting memory if I added that memory to QA, opposed to giving that memory to production. And so the rule of thumb is, there in an AWR report, Oracle's Automatic Workload Repository report, there's an SGA target advisory that we go to. And we look at that and we say, where's the sweet spot? Where do we want to put that memory? Where do we want to go? And that's what we take. And that's what we do in our sizings. And I get a lot of heat for that, but that's where the database really runs well at that point. And then I cut back the memory as much as I can. And this is virtual memory. So a lot of shops run 3-to-1, 2-to-1 overcommitted memory. That's up to their VM administrator, how they want to run. And I'm okay with that. And whatever velocity says, whatever the paging rates are, that's up to the administrator. But from a DBA, I size the virtual amount of memory, and the SGA is the biggest piece of that, how much I need for that. Did that answer the question? So in this case, there's all kinds of flags. I think even the velocity MIB checks, the SGA advisory and what would be the optimal setting. So I think kind of a little quiz the audience here. What's Bill Bittner's favorite expressions? It depends, right? Well, my favorite expression, and what enough people aren't doing, is you should be using large pages or huge pages for your Oracle databases. It's such a, you get this 10% performance boost, but it also keeps stability of the system, like it runs a lot more efficient. And I think velocities reports show that. I think you guys have it in there. I just think it's something that every single database I run with, I automatically put it in large pages. I configure it, just automatic. Because what happens if you've got the databases that keep growing 30, 40, 50, we've seen it at trading at financial firms, 9:30 in the morning, their users spike. They go from like 200, 300 to 5,000, and their page table memory goes up and spikes, and it just runs, the database just runs bad. And it doesn't page out page tables properly. You run into stability problems. But when we put it with large pages, it's more stabler. They can take those spikes, and the system runs a lot better. So this is what I preach every time I set up a database, is large pages. So we talked about Swing Bench. I kind of showed you the tool. This is where you can get it. It's a good simulator to try. Like I said, you want to try a couple tools. You want to try your own workload. You want to try, silly little Oracle benchmark's a good tool for just doing a small little test to say, okay, is dmcrypt going to help me or not? And this Swing Bench is kind of simulating more of a user workload. And this is kind of what we do. We don't use one tool. We test with 3 or 4 tools to kind of make sure that come to a consensus. All right, so Oracle I/O tuning. We spend a lot of time on this. This is for open system style storage. We always set up what the vendors recommend, whatever the, IBM or EMC. Is it EMC or Dell? It's Dell now, Dell. Hitachi, whatever the storage vendors recommend, we put their recommendations in here, and we go with those values. And then I always set up aliases down here so that it's easier to configure the disk for Oracle. And this is an example that we did at a proof of concept where we added 2 fiber channel cards. We went to 3 paths, 4 paths, 6 paths, 12 paths, and multi-pathing. And you can see the IOPS percent improvement is 12x, for running a lot of high workloads. So Oracle does a lot of I/O and can perform really well, and it can use the paths. For DASD, I was gonna, that demo I did in Providence, it kind of showed going from DS8800 to flash system. Well, I think they were sitting in the audience last time because they upgraded their DS8700. They got upgraded the Z to 16 gigabit cards, and now you don't see that delta anymore. It's running a lot better. So Hyper-PAV and setting up your DASD volumes, what Hyper-PAV does, it provides more paths to the disk. So basically, ZVM does one concurrent I/O at a time to each DASD device that's available. By setting up Hyper-PAV, it sets up many more paths so you can get to that disk device. And an open system LUN, by default, has 32 queue depth, I guess is the best way of saying it. And you don't need 32 because you never really queue it up, but the general rule is 4 or 5 at least. So this is what we do, is we set it up with the commands in ZVM here. Okay. How are we doing for time? Lots?
13 minutes.
13 minutes. So just going back to the kind of the summary of what we talked about with pervasive encryption, it's a really good story, right? We can now use deencrypt to encrypt our Oracle database and get that compliance check now. The penalty is low, 2 or 3%, and you test your workload. Every workload's different. But from our preliminary testing, and we're working on a white paper, the International Competency Center, they're working on publishing formal numbers. And we're not allowed to publish actual benchmark data, but we're allowed to show percent improvement. So that's the key. So we're working on doing all that stuff, and I think there's good things to come in 2018 and 2019 with what the Linux distros are doing. And for Oracle workloads, I think that our first at enterprise, try to get this solution for people that never touched a Linux One system. I think this is a really good solution. So.
When did you say the white paper will be?
It's in progress. It's got to go through lots of, it's got to go through distinguished engineers. It's got to go through, those could take years. No, they've been helped quite. Mike and his team, they guys just been the red paper, and we've been using Germany, the team, Eberhard Posch, and everybody's been really helpful in this topic. So thank you to everybody. Really, it's been a big help. So the red book especially, that was really, it's just so easy. Just 1, 2, 3, done. So I think that's really the big thing. So I think we're giving you back a couple minutes. So make sure you do the evals. If there's any other questions, happy to take them. But thank you for coming.